Starting from this video, we will start statistics. Before we started probability theory, let me firstly explain what is the difference between probability theory and statistics. Probability theory studies the questions if we know probability mass function and probability density function of some process or experiment, then in fact we know everything about the random variables, right? So probability theory studies how we can calculate some parameters of the functions, how we can calculate probabilities, and so on. And mostly in probability theory we took some models for which we know these functions, or for which we can easily find them. Okay? And what about statistics? Statistics, this is the part between let's say a bridge between real life things and probability theory. So statistics try to answer the question, what is probability mass function and probability density function of some real life processes. Okay, so before we considered examples where these functions were known, and from now on we will assume that we don't know anything about these functions. We only are given some text problem and we will try to study this particular text problem. What can we do with it? Okay, so you have a text problem and the main task of the experimenter to find as much as possible about the probability mass function or probability density function of the random variable. Since again, if we know this function, we know now everything, right? So our task is to find this function. And in fact, we will not study statistics so deeply, so we will not be able to find precise functions, but at least I'll try to give you direction to answer this question. And what we do in statistics, first of all, we have to conduct some experiments. So assume that we're interested in some problem. Let's say we want to know the probability mass function of machine breakdowns. What we do, we make some records. So what we do, we study these breakdowns during some time. So this is called experimentation. We kind of make experiments and make the records from this experiment. So this making records is called collecting a data set related to particular question, to a particular random variable. And this process is called taking sample from population. About sample and population we will talk a bit later more. So what is basically sample? This is the collection of data which you got from some experiment. Okay, and now assume that you have such data, and what we do next? We try to describe quantitatively or make some summary about the sample that we got. This is called part of statistics, which is called descriptive statistics. Then after this we analyze the data that we have, and based on the descriptive statistic we make statistical inference. What is statistical inference? We make conclusion about all the population that we study. So of course it's not possible when we do experiment, it's not possible to consider all possible things. For example, if we talk about machine breakdowns, it's not possible to study all machine breakdowns in past, in future, all of them, right? So therefore we have to make some restrictive data, restrictive records, and based on these records we have to make conclusion about all machine breakdowns in future, right? So we want to predict something. So, and this part, making conclusion, is called statistical inference. This is another part, important part of statistics. And we firstly start with this descriptive statistics. And the properties of descriptive statistics can be divided into two parts. The first part is central tendency, measurements of central tendency are mean, median, and mode. I'll give the definitions a bit later. And also variability, so how the data spread over the state space. Okay, and for variability we have standard deviation, variance, it can be minimum and maximum variable of the data, it can be kurtosis and skewness. Okay, so all these things are parts of descriptive statistics, and all these things they comes from a sample that we collect at the beginning. Okay, and this in this video and subsequent videos we will study how we collect data sample from population. We'll also look at some graphical representations of data, because if you have a lot of data, it's very useful to see what's going on there using some graphics. And also we will calculate some useful summary statistic, which is part of this descriptive statistic, which I just explained. Okay, and firstly we start with notion of a sample. So again, let's come back to this machine breakdowns example. So remember that there were three causes, or we consider three causes of this machine breakdowns. This can be electrical, mechanical, or operator misuse. And of course, in practice, if you just started this research, just started studying this problem, you don't know the probability mass function at all, right? So therefore, what we do, the first obvious task of the experimenter to collect a data set relating to these machine breakdowns, right? So in fact, what we do, maybe for some time, each time when we have some breakdown, we write down this, what happens and what is the reason, right? This is what we are going to do. And this will be our sample, example of a sample. Next example about the milk containers. You can notice that if we talk about the weight of a milk container, the weight can be numbers in some interval. So this is continuous random variable. The previous random variable was discrete, right? We had only three possible breakdowns. So here we have continuous random variable, and assume that we don't know probability density function for these milk containers. And what we need first to start the problem, we need to take some milk containers and measure their weight, right? So our sample will be just, for example, we take n containers, we measure their weights, so we get just n tuple of numbers. Each number is the weight of a particular milk container. This is another example of a sample. Okay, and it's important, of course, to understand how good the sample you have. So is it correct way to choose this particular or that particular sample for your experiment, from your experiment? And in order to judge the quality of a sample, it's often useful to decide, is your sample representative or not? And to do this, we have to understand the we have to look at all the population. So what is population? Population is everything what you have. In fact, this is the set of all possible things from which you get your particular sample. For example, if we look on these milk containers, the population is all of the milk containers. And how we can choose a representative sample? A representative sample, in fact, usually in practice is a synonym of a random sample. random. So we choose milk containers randomly without any reason to choose that or this particular container. So for example, you can choose every 10th container, for example. Doesn't matter. It's not good if you choose, for example, all your sample containers in one box, or containers which were filled only by maybe one machine out of existing 3 machines. So this is what I explained here. Assume that a company has 3 machines that fill these milk containers. Of course, it's not good if you take your sample only from one machine, right? Because you study the milk containers overall from all 3 machines. And if you do this, you have to select and weight milk containers from all 3 machines. In fact, if you have 3 machines, it's better in fact to split and study 3 different samples, because each machine may have its own problems and so on. Okay. In fact, what can we now say? In fact, it depends on the experimenter, on his view of the problem, on his experience, what to choose to be population or a sample. For example, if we will talk about these milk containers, and we know there are 3 machines, right? We can consider a population to be all milk containers from 3 machines, right? And then the sample will be chosen randomly from 3 machines. But maybe someone else may study differently, or he may maybe choose population as milk container from first machine, and then the sample will be all milk container from the first machine, right? So it depends, of course, as I said, on the investigator. So we can say that the notion of population and a sample are quite flexible. It depends on the question, on the in fact view of the experimenter. But there is of course some general definition of population and a sample. And population, please read here, consists of all possible observations which you have, which are available for this particular probability distribution, for this particular random variable. A sample is a subset of the population. So the subset which is in fact available to you, right? For example, the milk containers which you had maybe 1 year ago, they're not now available to you. You cannot weight them, right? But the sample is a subset. If population all the milk containers, you can only measure the milk containers which you have now, which you produced right now, which you can weight right now, okay? And a random sample, what is this? This is sample which is chosen just randomly from the population. And usually the random sample is called representative sample of the population. Okay? And if we talk about some data sets that we may get in our sample, there can be general types of the data set. There can be categorical or nominal data records. If we have some just different types of observation taken, for example, we had, let's say, for machine breakdowns, we had only 3 categories, right? This is categorical data. And another one, if you have only two things, for example, if in machine breakdowns we had only, let's say, mechanical and electrical, this is called binary variable. So only 2 categories we have. There are also examples of numerical data, of course. There can be integers or real numbers, depends on the problem. Okay, so let's come back to the machine breakdowns and let's see what can be a sample. Let's say some engineer decided to study this question, and he collected a data set of 46 observations. So let me show you how it looks like. So usually this is like a table, and here we describe the cause of the breakdown, and here are the frequencies, how often we meet this among 46 observations, right? Electrical we had 9, mechanical we had 24, misuse we had 13. Okay, and he collected these breakdowns over 1 year, and he now has this sample. So they were just the observations which are available to the engineer, right? First question, what is the population from which the sample is drawn? Of course, the population, all breakdowns during the year and all breakdowns in previous years, in future years, so all possible breakdowns for this particular machines, okay? This is population. What about our conclusion? Can we use this data set, this sample, to make conclusions about all population? So in which case we can say that this sample is representative sample. This is question again which you have to think about deeper. There is no unique answer to this question. So of course to this question may answer only people who work with these machines, who know them well, right? And of course this sample can be representative if this particular year from which we took this sample is a representative year. What does it mean this is representative year? This is just a usual year. Nothing happened in this year, nothing unusual. For example, maybe if maybe some new person came to work with these machines, there can be more operator misuses, right? This is something which is unusual. Or I don't know, what can it be? Maybe they changed something in the machines, which also can be considered as unusual thing this year. So if this year is representative, then yes, this sample is also representative, right? This what we can say. Okay, yes, only if this data is representative of future years. All right, so now let's look at another example. Defective computer chips. We already had this example. And we had a company who sells computer chips in boxes of 500 chips in each box. And now we don't know what is the probability density function, what is the distribution, and the company wants to investigate what is the distribution of number of defective chips in the box. So what is population in this case? Population is just all boxes produced by that company, right? Produced by that company over the years. It can be future years, past years. So all possible boxes from this company. How we can choose a sample randomly? Again, we can maybe take let's say every, depends on how many boxes they produced, can be every, let's say, 5th box, and determine how many defective chips are in this box. So this is as example. Of course you can choose any other way to choose the random sample. Okay, for example, they totally choose 80 boxes, and they calculated number of defective chips in each box, and they realized that there are no defective chips in 4 boxes, 1 defective chips in 12 boxes, 2 defective chips in 18 boxes, and so on. And they noticed that the highest number of defective chips was 8 among these 80 boxes, and there are no boxes with 9 and larger number of defective chips. So what they have in this particular sample? Okay, let's move on to another example. The metal cylinder production. Again, we have a company which produces some cylinders, and the company selects randomly a sample of 60 cylinders and measured their diameters. Our random variable for metal cylinder example will be diameter of the randomly chosen cylinder. And what can be the population for in this case? Of course, population, all cylinders, be the set of all cylinders produced. Of course, produced by the same company over in past, in future, so over all years. Okay. Another example, again, milk containers. We already discussed it. Let me give you example of a sample. Let's say we choose randomly 50 milk containers and we weighted them, and we got for each container we got its particular number. So the population is, of course, set of all milk containers that we have in this particular company, or if we look at a particular machine, from a particular machine. Okay, these are examples of samples, and we will study these particular samples later. We will measure some things for them. We can find all these samples in fact in Excel. In e-class you can find, in week 10, in day 10 e-class you can find these Excel files of the samples. So for example, defective chips. Let me show you what we have. So these are all the data sets for week for chapter 6 for the book. So for example, here you can see the milk weights, metal cylinders. So all of them are here. Let me open one so you can see the metal cylinders. So is this data set. So you can see it here, and we will work with this data set in Excel. So from now, please try to find Excel, install on your computer. There is also Excel online. You can use that one as well, also possible.